problems on Biot-Savart's law. Let me recall Biot-Savart's law in brief. It says moving charges induces magnetic field around it. In other words, in the different pretext, a current carrying conductor induces magnetic field around it. Since the charges are moving in the conductor carrying current, this is the pictorial representation of Biot-Savart's law. This straight line indicates the current carrying conductor of current strength I. Around that conductor, surrounding that conductor, magnetic field is induced, and the direction of the magnetic field is given by the right hand rule. It says if you hold a conductor with the right hand, directing the thumb in the direction of the current, the fingers curl around. These are the fingers curl around, indicates the direction of the magnetic field lines. So magnetic field lines are surrounding this at every point in concentric circles. The direction is, this is the direction, for this direction, clockwise direction. And this is what the pictorial representation of Biot-Savart's law. And mathematical statement of the law is this. It is in the differential form, that is dV by dl. If we take it on the left hand side, it is mu naught by 4 pi into I sin theta by r square. Rate of change of magnetic field with length of the conductor is given by these factors. This is, the B represents the intensity of the magnetic field at any point in the space around the conductor. This magnetic field is a function of current strength in the conductor I and the distance of separation between the point and the conductor R as r square, and theta is the angle between the two lines. One line is a straight conductor, other line is a position vector here of the point with respect to the length of the conductor, position vector. The angle between these two lines is theta, sin theta. So magnitude of B depends on all these functions. They are directly on these functions and inversely on this function R, square of the R, where mu naught by 2 pi is a constant, magnetic constant. So this is the differential form of the law, and for the integral form of the equation for a finite values, the equation is this. For a conductor of finite length, a conductor of finite, what is infinite length? Infinite means length that is measurement is beyond our limit, infinite length, and the point that is R is the perpendicular distance between the point and the conductor. Pictorial representation of the conductor of infinite length and the point where the magnetic field is induced due to current flow in the conductor. It is given by this equation. Mu naught I divided by 2 pi r for infinite length. Suppose the conductor is semi-infinite length, that is the perpendicular distance between the point and the conductor is conductor at one end of the conductor. That is the direction of the electric current. This is a pictorial representation of a conductor of semi-infinite length where the point is placed here, or is a perpendicular distance between the point and the conductor like this. It is given by this equation mu naught I divided by 4 pi r. But that this is actually divided by 2. We get this equation. These are the equations, mathematical definitions of Biot-Savart's law, differential form and integral form for infinite length and semi-infinite length. Now the problems, let us move on to the problems one by one. The problem is given, the first problem is this. An element of dl equals dx I unit vector. This data represents or indicates a Cartesian coordinates, that is dl is in the direction of x. dl means a small value of l. It is same as dx, small value of x on the x axis. And the current direction is along the x axis. That means the pictorial representation of this data is the one it is drawn over here. X direction and y direction, Cartesian coordinates in one plane. Dx is given, this is the dx value, and the value of delta x is given is 1 centimeter at the end of the problem. And this delta x is placed in the origin. What is origin? This is the origin of the Cartesian coordinates. Here it is placed, delta x value, small value. And current is carrying in this direction. What is the amount of current? 10 amperes. And what is V on the y-axis? That is on the y-axis, perpendicular direction like this. What is V at the point here on the y-axis from the origin? 0.5 meter. 0.5 meter from the origin. That is the data in the pictorial representation. So you write the equation, that is delta x equals 1 centimeter. So the value is very small. We can assume it as dl, dx equals dl, that is dl, dx is dl. Shall write the equation for this data. Since value is small value, a differential form of the equation. Biot-Savart's law, the same equation. Magnitude is asked to calculate dB. Write the same equation, and all the data are given. I equals 10 ampere and dl equals 1 centimeter. 1 centimeter you have to write it in SI units. 1 into 10 to the power minus 2 centi, 10 to the power minus 2 meter in SI unit. And the theta value is understood. The angle between this line and this line, that is theta, 90 degree. That is r distance, that is a conductor here. Theta is 90 degree. Sin theta equals 1. Sin 90 equals 1. Substitution into the equation. Here mu naught by 4 pi value, constant value, is 10 to the power of minus 7 in SI unit. 10 to the power of minus 7 in SI units. And I value is 10. DL value is 10 to the power of minus 2. Sin theta is 1. R is 0.5. Since it is whole square, 0.5 whole square. Simplify this. We get this value. 4 into 10 to the power of minus 8 Tesla. Unit of magnetic field in SI, Tesla. 4 into 10 to the power of minus 8. Since dl is small, dB is small. Differential expression. This is the solution to this problem. Next problem is, infinitely long straight wire carrying a current of 35 ampere. Calculate B at the point 20 centimeter from the wire. Let me put this data in pictorial form, that is pictorial representation of the data. This is what pictorial representation or diagrammatic depiction of the data. The conductor, it is a conductor carrying a current. The strength of the current in the conductor is 35 ampere, and what is B? That is the point you are taking. You have to calculate the intensity of B at this point. The point is at 20 centimeter from the conductor. That is R value. 20 centimeter is R. R value is 20 centimeter. I value is 35 ampere. B to be calculated and should be converted into SI unit. Centi equals 10 to the power minus 2 meter. Write the equation. What is the equation? That is for the infinitely long straight wire. The equation for a conductor of infinite length is B. That is this equation. Write the equation and substitute into the equation. Mu naught equals, what is mu naught? 4 pi into 10 to the power of minus 7. Since I said mu naught by 4 pi is 10 to the power of minus 7, mu naught equals 5 into 10 to the power of minus 7. I value is 35, 2 pi, and R value is 20 into 10 to the power of minus 2 in SI unit. Simplify, pi cancel, and simplify this. You get 35 into 10 to the power of minus 6 Tesla, B value. That is the strength of the magnetic field at this point. This point is about 20 centimeter from the conductor. It is a perpendicular distance between the point and the conductor. This is a solution for this problem. Similarly, we go for solving the third problem. I will read the problem. A long straight wire in the horizontal plane carries a current of 50 ampere in north to south direction. Give the magnitude and direction of B at a point 2.5 meter east of the wire. It requires diagrammatic depiction of the data. This is what I have put pictorial representation of this data. What I read here, it is in the diagram with all the data. What is said? A current carrying, what is that? The conductor is in the direction from north to south. Current is flowing. This the conductor is on the plane, horizontal plane. That is similar to the board. It is on the plane. This is a conductor. direction of current is from north to south. What is the amount of current is flowing? The amount of current flowing is 50 ampere, and you are asked to calculate the direction and magnitude of B at the point on the east. We are north and south on the east at a distance of 2.5 meter. Then perpendicular distance between the point and the conductor. If this is north direction and south direction, the direction like this, the left hand side is east, the horizontal like this, that is a line, and right hand side must be west. That is why I have put this point on the left hand side, a straight line at this point, 2.5 meter away from this. And using this data, let us calculate what is the magnitude of B at this point. Use the same equation, because this is applicable. What is that? The diagram says it is a conductor of infinite length. Equation is applicable is this equation, B equals mu naught I divided by 2 pi r. Substitute into the equation. I said mu naught in SI unit is this. I equals 50, strength of the current. R value is 2.5 meter in SI. 2 pi. Simplify this. You get this value 4 into 10 to the power minus 6 Tesla unit magnitude. This is magnitude of B. And one more, you have to calculate what would be the direction of the magnetic field at this point with respect to the current carrying this conductor. Apply the Biot-Savart's law right hand rule. That is, if I hold the conductor like this, indicating the direction of the term in the direction, directing towards the direction of the current thumb. These fingers curl around indicates the direction of the field lines. So that is why when you come like this around it, so passing through this point, what is that? The direction is here like this. The lines, circle lines, and tangent to the point is, what is that? Tangent to the point on the circle like this direction. It is like this. Tangent to the point on the circle at this point is always a straight line. Direction is, this is the direction of the magnetic field. Direction of magnetic field is perpendicular to the plane in the upward direction. That is outward. This symbol indicates direction is outward. That is the direction of the field. Says B is perpendicular to the y or the plane, because this is also perpendicular to this y as well as plane in the upward direction. Outward direction or upward direction. So direction always we get it by using right hand rule, and the magnitude by using equation. And the last problem on the same the law. Here the power line is mentioned. A horizontal overhead power line is mentioned. It carries a current of 90 ampere. The direction of the power line in the east to west. East to west direction, that is direction of the current in the y is east to west. What is the magnitude and direction of B? The point due to current, due to this current, it is about 1.5 meter below the power line, below the line. Let us go for a pictorial representation of the data. When you put it in a proper way, then we can understand clearly the problem solving easier to solve the problem as well as direction of the magnetic field. He said east to west. Conductor is east to west. That is the power line. I am taking one of the line, power line. Current strength is 90 ampere. Direction of the current is this. And I given the point. What is that? He said the point below the line, not above the line. Below the line, at a distance of 1.5 meter. 1.5 meter. At this point, what is the strength of the magnetic field at this point due to this power line, and also direction of the field, magnetic field. For the calculation of magnetic field, use the same equation because it is a power line means infinite length. Mu naught I divided by 2 pi r equation is suitable. Write this mu naught in SI, this is the one in SI in it. I value is 90 divided by denominator 2 pi r into r value is 1.5. Simplify this, you get this value 12 into 10 to the power minus 5 Tesla. This is what we get. Magnitude of the magnetic field, magnitude or intensity of the magnetic field at this point is 12 into 10 to the power minus 5 Tesla below this power line. What is the direction of the magnetic field? Apply right hand rule. Now the conductor is like this. You have to hold the conductor like this, directing the thumb in the direction of the current like this. So the curling fingers, the fingers curl around is like direction like this. That is inside. That is star at this point is inward. So the lines, what is that? Always circular lines are covering, magnetic lines suppose covering. Direction is like this direction. This is what? Direction is like this direction. At this point, what is that? The point on the line that is tangent to the point at the line is the direction of the magnetic field. He says that is the inward direction like this. So this is east west. Direction is always what is that? In this direction. That is direction here. It becomes north. That side south. So it is south direction. If we say east west in this line, right hand side is north, left hand side is south. Magnetic field at this point is in the perpendicular direction at this point towards south direction. That is the direction of the magnetic field under this power line direction. It is given the direction like this. So this is how we can able to solve the problem. While solving, we need to put this data into pictorial representation, then it will be easier to solve the problems. This is how we have solved all the problems this time.